In a previous video, we went over how to store grades in an array, create an average. But say we wanted to actually get to search that array for a particular item, and we can do that using a sequential search. It's a very simple search, and it's a very basic way of sequencing through your array. Now, sequential search algorithms use a loop, and these are sequentially step through the entire array, compare each element with the search value, and then stop when that value is found, or throw back an error saying the value is not found. So what we're going to do here is we're going to use a sequential search algorithm to search through a array of grades that we create. And so what we're going to do here is we're going to basically erase everything from here on up, this last for loop, and we can go ahead and input our sequential search algorithm. All right, and so here we want to ask the user, system out, print line, what have you, which grade do you want to look for? And then we'll go ahead and we have to initialize a double here, but then it'll be easier if we create a method, an external method to actually do this search. So what we can do here, we'll go ahead and go down here and we'll create a variable, a method that will return a double, and it will return whatever we're looking for, right? And so we'll create a double returning method. We'll call it sequential search. This method, and we'll say it takes in the arguments a double array, and then a value, the value that we're searching for. So we'll pass the grades array to this method, and then we'll also pass what we're looking for in this method. So let's go ahead and do that. And what we're going to need is an indexing value. So let's call it index. We're going to need a value we'll call element, and that element is the value that is found that we'll pass back. And then we'll also need a boolean, and we'll call it found. To tell to tell the program whether or not it found the element or not. So we'll set index equal to 0, and then we'll say element is equal to -1.0, since it's a double. And it has not been found, so that's false. And so we'll use a while loop to actually execute this, and we'll say while not found, and index is less than the array length, then we want the loop to do another if statement. If the array index is equal to the value we're looking for, then first thing we want it to do is set found to true, and then we want to set the element that we want to pass back equal to the array index. Right. Otherwise, we want to increment through the array again. So let's look what we did here. We said while the element is not found, while this is false, and index is less than the length of the array, we want to increment through this array unless the value in that index is equal to what we're looking for, then we want to set found to true, so that it exits the while loop, and then we want to dump the contents of the element of the array into the variable element. All right, and then we want to return element. So that's a simple sequential search. All right. So what we're going to do up here is initialize double by saying search is the variable search is equal to sequential search. We want to pass the grades array, and then we'll say the value that we want to look for is keyboard dot next double. And what we're doing there is saying whatever the next double that the user inputs, that's what the grade we're looking for. And we're going to use a if statement. So if search is equal to -1.0, then that means that the search has failed. All right, and that means that the element is not found. So we'll say system.out.println, and we'll say grade not found. All right. However, else, if the search is not equal to -1, then system.out.println, or actually it'll be a format grade found, and we'll put the flag to point 2 to the we want to format it to 2 levels of precision, and we want to displace whatever search is, and that completes the algorithm. So we're still throwing up an error because we still have index left over from before what this program used to be. We don't need that variable anymore. So, and as you can see, we're checking out here. So we'll run this program again, and it's parsing. So we'll enter 98, 97, 86, and 85 as the 4 student grades, right? And we'll enter, it gives us the average. Now, what grade are we looking for? We say we want to say find 86. 86 was found. Hooray. But let's say we, again, want to put in input 86, 98, 76, and 85. And say we want to look for 56 as a grade. Grade not found. So, advantage to this algorithm is relatively simple. It is advantageous because of that, but the problem is that it has to step through every single element of the array until you find it, and so that could be up to n times. So the length of the length of the array on average would be n divided by 2. So the average length of the array, that's how many iterations has to go through the array to actually find the element you're looking for. So that's not advantageous. But we'll talk about a selection sort and binary searches, which are a little bit more efficient and better for larger data sets.